Would you use a stem and leaf plot or a histogram to show distribution? And I guess we'll start out with, could you tell me the difference between a stem and leaf plot and a histogram?
I know what a histogram is. I'm not sure what a stem and leaf is.
Okay, so the stem and leaf looks like this. It's got like numbers. I'll just put a couple of numbers like that, X, 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 something like that, maybe. And a histogram is with the bars, except they're together. Let me redo that.
Okay. So
All right,
then probably,
so notice here, this is a big difference. Notice that I'm plotting every individual point.
yeah, so probably histogram.
Exactly. And you want to say something about the fact that with a lot of data points, it's easier to show the kind of the bounds of them or the buckets that they fit in, the grouping, rather than plotting all the individual ones.
Okay, so then probably histogram, because you can plot
Yes.
more values. Hello?
Yep. Yep. That's it. I mean, I don't know how much more you want to say, but yes, that's it.
Okay.
Sorry about that. I give you some time. These aren't like the numerical ones where you just write down. They require sort of sentences to think about. All right. For a symmetric distribution, why is the mean used to describe the center and the standard deviation used to describe the variation? For a skewed distribution, why is the median used to describe the center and the 5-number summary used to describe the variation? So we're going to draw these here. This is a symmetric distribution. It uses the mean and the standard deviation. And for a skewed distribution, so I'll draw a skewed distribution. That's not great. Let me draw a little better one. It's kind of got a bigger tail, comes up like that. Yeah. This one is skewed on the right. We use the median. And this is the 5-number summary. Okay. And so the answer to some of these questions have to do with the pictures here. Okay.
All right.
The pictures tell you that, okay, on the right, there are potentially outliers. Any idea what an outlier is?
Something that's it's like if you had numbers 1 through 10, then you had 25.
Okay, so it's called an extreme value.
Yeah.
So the information you're looking for is that and I'm not sure what to write this, I'll just maybe put it in the middle, is that outliers affect the mean, but not the median.
Okay. So would that be our answer?
Well, that's part of it. I mean, that's why you use that's why I use the median on the right, is because there's outliers over here. And the same thing for the 5-number summary. So the standard deviation, it's not just the mean, the standard deviation is also affected by outliers, but not the median and the IQR or the interquartile ranges.
Okay.
And that's kind of it. I mean, there's kind of not really like, and this mean always goes with the standard deviation. The 5-number summary always goes with the median. That's kind of it for figuring this stuff out. Like they go with one, goes with the other.
Okay.
I'm really shocked that you're being asked these questions. I mean, but I guess that is kind of the standard thing right now. A lot
Yeah.
of students are doing the statistics unit at the end of the school year. All right, so let's see here. 14, 15, sorry, up to 15. All right, so the one thing you can kind of do when you get a histogram, excuse me, is you can draw a curve that fits it. And then the one on the other one here kind of looks more like this. The top one's got kind of a skew
Okay.
left. The bottom one looks kind of symmetric.
Okay. So for the bottom one, so B you would use mean, right? Because there's not too many outliers.
Do that one more time. Which one? Which one?
For B, would you use mean, but then for
Yes,
A,
exactly.
you would use like median?
Exactly. Now it says here to compare the distributions using their shapes. So you want to say something like town A is skew left. Town B is symmetric. And then that's what you just said, measures of center. So we would use the median for town A and then the IQR or the 5-number summary. And then for the mean, you use the standard deviation.
Okay.
Any questions on that?
Nope.
Okay. So number 16 is kind of where you would start in a more traditional statistics class. They would give you the data. In this case, they've sort of processed it for you. They put it into buckets. And so you have to create a histogram for each. Now, double histogram, let me just double check if they want those to go side by side or on top of each other. Any idea from the book what it says? Double histogram. Okay, they're side by side. All right. So to do this, gotta be very careful here, doing this as accurately as we can. All right, so we're gonna do A first, and then B. Start with A and then B. We're going to start. A is 5, so 1, 2, 3, 4, 5. So that's A. And I have the advantage here of switching colors. B is 0 there. So we're plotting that first one, and then you're supposed to label, 8 to 10, for example. I don't have a ton of room, so you might, try to squeeze it in there 8 to 10. For this first one, I guess I can use both those, but we really should label A and B. I don't know, we'll go 8 to 10 like that. Let's put a 5 there. And then we'll do the same thing for the 11 to 13. So 9, 6, 7, 8, 9. And then the other one is 2. So go height of 2. It's 11 to 13 there. And then 12, go up to 12. And then 5. That's 14 to 16. The last one there, or next one there is 4 for restaurant A. 4 for restaurant A. 7 for restaurant B. And so what you might be noticing here, I'm noticing the red ones are kind of getting bigger and the black ones are going big, and then they look like they're coming back down. Let's see that that's 3 and then 8. and then 0 for that one, and then 6 for the last one here. It's kind of, I mean, it's kind of busy work. You would normally do this in software. You would not typically do this by hand. But of course, you know, your guys are in the classroom, so they probably want you to do this by hand. So I actually think it's harder to do this with the double histogram. I think it's easier to kind of see them top and bottom like we had in the previous problem. But someday you may work for a company where they want the charts this way and people want to see the, you know, information stacked side by side because they think they can glean something from that. I have no idea, but something to think about. All right, so next we should talk about the shape. You still with me, Braden?
What?
You still with me?
Yep.
Okay, so the shapes here. So like town A versus town B. A is kind of, you know, it goes high and then it comes down hill. And B kind of, let me draw B here with different color, starts low and comes like that. So they're basically flips of each other. Right? One is left skewed. One is right skewed. So this one is right skewed. And B is left skewed.
Okay.
The next thing it asks for is for you to just decide probably the measure of center. Yes, so measures of center. We would say median for both because they're both skewed. And then variation. Variation, we would say interquartile range or the 5-number summary. It's specifically the IQR is what they typically look for here.
Okay. Hello?
Yes, is that okay?
Oh. Yeah.
So I don't know how long it takes to get things down. I'm also, in full disclosure, I'm pretty exhausted, long day here. So
Yeah.
taking breaks is just because I'm trying to collect myself. All right, number 19 looks like it's next. I mean, hopefully you've seen a number of these in a row, so you're like, okay, I get it. It's like they're skewed, not skewed. Boy, another one. Are you using the calculator at all for these? Or all by hand?
I can be using the calculator.
What I mean is like the calculator has built-in capabilities to draw some of this stuff. And I guess I'm asking, did you guys do any of that in class?
Oh, we don't use calculators like that. We use
Okay.
like scientific calculators.
Yeah. Okay. Yeah, that's good to know because this, for example, this can be done with some of these can be done with a calculator and software and they're very fast, but it's like, nope, you got to do them by hand. So we're going to do them by hand. All right. So hopefully you guys talked about box and whisker plot.
Yes.
Now, the fact that that's a double box and whisker plot, that just means that um, there's like one on top of the other. All right. So the place to start here is with the median in both. And actually, I do think I'm going to need a little more room here. So I'm going to come down here. So I'm going to put the median. I'm going to call this. Let me just get a scale of the numbers here. All right. So this is going to be 1200. And we're going to go up by each box will represent 100 on my grid here. So we're going to look at the first one. So you start with the median and you draw a vertical line at the median. To go to the third quartile, you go right 1, 2, 3, 4. like that.
Okay.
Okay. And then you go left to 800. So 11, 10, 9, 8. So this one's kind of symmetric. You can see that there. And then you draw a whisker now to the min and to the max. So the min is 250. So it's 7, 6, 5, 4, 3, 2. So right kind of there, you draw kind of a whisker to the min. And then you similarly do the same thing to the max. The max is 2150. So you got 17, 18, 19, 20, 21. So kind of right in there is the max. And that's for freshmen.
Okay.
All right. And we do the same thing for the sophomore. So I'll switch up the color here. For this time, we're starting at the median, which is 2000. So the median is roughly there. That's 2000. So the idea is to get the scaling right by having kind of using the right increments. And then quartile 3 is at 2200. So that's kind of there. Draw a little box. Then you find quartile 1, which is 780. That's way over here. Pretty wide. And then the max is 2400. So kind of right there, 2400. And then the min is 360. So kind of roughly figure out, okay, that's 300. So it's a little bit to the right of that. Somewhere in there is the min.
Okay.
All right. So now we can talk about the shape of each distribution. The black one looks kind of symmetric. I don't know if you can see, like, to me, it's like the same amount going out each way.
Okay.
Is that kind of, do you agree with that?
Yeah.
All right. Now the other one's a little bit harder to see. It's the, you almost need to draw it above it. It looks like this. This blue one here.
Okay.
So that one's left skewed. And I think it really helps to try to draw this out like this. I mean, it should be more centered above the median, but or the bell should be at the top of the median, but close enough.
Okay.
What else does it ask here? Or is that's everything? Okay. All right, part B. Part B says to compare the number of songs downloaded by freshmen to the number of songs downloaded by sophomores. So we're basically looking at the medians. What can you say about the medians of each group, or which is median of, I'm sorry, I don't want to say this. Actually, I'm not quite sure what it's asking for, because we could say like the median of sophomores is higher than the mean of freshmen, but we actually know the mean of both. So we actually say that on average, sophomores download more than freshmen.
Yeah. Okay. So.
But really, you're supposed to say, well, I should use the median for this one and the mean of the other.
Okay. So sophomores download more music.
Yes.
Okay.
All right, so let's move on to the next question. Let's see your part C. All right, about how many of the freshmen surveyed would you expect Let me grab the question. About how many of the freshmen surveyed would you expect to have between 730 and 1570 songs downloaded on their MP3 player? If we go back and look at the freshmen, that's the black one
Wouldn't
here.
that be like the
So
third quartile?
yeah. Did I get these wrong? 730 and 1570. I think so. To me, they're asking about 730 and 1570. So to me, they're asking about this see where this is about 800 and this is about 1600. They're kind of asking about that middle 50%.
Okay.
Because 730 is a little bit below this, 1570 is kind of like right in there roughly. So it's about 50%. Any questions on that?
No, I'm trying to
Okay.
understand it.
Yeah, it's kind of it looks a little weird because you kind of are, they usually pick numbers that represent the like bounds. They ask you like how many would you expect between 800 and 1600? It's 50%. So the idea is, maybe that's what's missing here, is that in each quartile there's 25%. 25%. 25%. Even though it's really wide, it's still 25%. Even though it's really narrow, 25%, and so on. So your answers are typically a derivative of like 25. It's like, oh, it's 25%. Oh, it's 50%.
Okay. So 50% would be
Yeah.
400.
Yes. All right, let's see what's next. So I got to keep going back and forth here. So if you survey 100 more freshmen, okay. If you survey 100 more freshmen, about how many would you expect to have downloaded between 310 and 1990 songs? So we have to now go back and look and see what percentage is between 310 and 1990 of freshmen. So that's about, well, I mean, it's a lot of them, right? It's probably almost everything, and maybe not, maybe kind of right in the half here, like 87.5%, because it's around the middle. You kind of
Okay.
see how I'm coming up with that, basically 310 is down here. I mean, you could cut off a little if you wanted. 25, 25, 25, but not quite all of this because it's kind of right in the middle. 1900's about halfway between that. So maybe 87, 85%.
Okay.
So we say, okay, it's about 85%. So if you survey 100, 85% of 100 is 85.
Okay.
All right. Anything else on that? Because I think we're going to do another one here coming up on 20. Is that right? Or are we skipping that one? We're doing 20. All right. So let's take a look here. All right. You conduct the same survey as an exercise 19, but use a different group. They gave you a different survey size. Compare the number of songs downloaded by the group of freshmen, number of songs downloaded by the group of sophomores. Okay. Okay, so we got to go grab, oh my goodness. We got to go grab the sophomore information. So I think we're supposed to
I'm
keep
not
that.
even gonna attempt to regraph this. I'm just gonna
Okay.
look at the graph I have.
All right. Let me get kind of something down here. I don't know that roughly. And then so the median's kind of important. 1670 versus 2000. So let me try my best to graph through 2009, 8, 16 right there, 1670. So it's gonna be a little bit more there, 1670, 2150-ish right there. First quartile 640. It's gonna be about there-ish. Okay. And then the minimum is 200, which is pretty low. Okay, somewhere right there. And then the max is 2400. So let's see here, right about there-ish. Okay. I mean, it's pretty, it's not terribly different, but it is a little different. Why is so that's so we're comparing them. I mean, there's a lot of similarities. Basically, the median is lower, but the min and the spread, but the spread of the data is about the same. So you'd probably see that. You'd probably say the median of the freshman is lower. The spread is about the same. The second one has a little more symmetry to it. This red one seems to be a little more symmetrical.
Okay.
All right, so next one here, it says, why is the median greater than the mean for this group of freshmen? And the reason is that it's left skewed.
Okay.
When it's left skewed, the median is greater than the mean. When it's right skewed, the median is less than the mean. And you're typically expected to know both of those for the class.
Okay.
All right. Okay, so we're up to 22 next.
Okay.
All right, this one we actually should have done first. This really helps to figure out distribution. I kind of attempted to do that a little bit ago. Let me grab just A, so I can kind of show you what to see here, what you're looking for. So A has a shape that looks like this. So you're looking for the graph box. I'm sorry, the histogram that kind of resembles this. And I think you can see that is B. Kind of resembles it. Maybe.
Yeah, that would go pretty well with that. And then B would go with A because of how close the slope is.
Agreed. And then C is the one that's symmetric. So it's going to have the same falling to the left and falling to the right. So there you go. There you have it.
Okay. I got nothing else for today.
Okay. Any other stuff for final exam reviews, stuff like that?
No, we covered all. That was the final exam review for today.
Okay. Well, this is new stuff. So what I'd like to do is pull up some questions that maybe you haven't seen in a while for final exam review prep. Would that work for you?
Yeah.
Okay. Just a moment to find some here. Okay, this is beyond. This isn't what you're doing. You're not in Algebra 2. I guess I need to specify Algebra 1. All right, give me just a moment here. We're never going to get through with that so quickly. All right. So this is something kind of you haven't done in a while. Let me snip this in. All right. Any idea if your final exam will be multiple choice, free response, or some of both?
Should be multiple choice.
Should be multiple choice. Okay. So this is kind of multiple choice, but it's not your classic multiple choice. It's really 3 questions. It's really saying solve A, solve B, and solve C, and one of them will have no solution. Do you remember what you're looking for if it has no solution?
Square root of a negative.
Okay, that's true for quadratics. This is kind of the reminder here. If you get x equals a number, that means it has one solution. If you get 0 equals 0, that means infinite solutions.
Oh, it's like 1 equals something
Yes.
else. It's no solution.
Yes. If you get 0 equals a number, no solution. So unfortunately, you do have to solve all of them, or at least guess really well. I would start with the easiest one, maybe on the left here, and seeing what you come up with.
So then 4x plus 8 is equal to 4x minus a is the one with no solution.
That is correct. Why don't you keep going with B or C? One of them should have no infinite solution. One should have one solution.
And it's 4x plus 4, negative 3x equals negative 3. C has infinitely many and B has 1.
Okay, very good. Make a new tab. All right. So just throw something kind of different at you here. Let's say I gave you a system of equations like this. How would you solve this system?
Substitution.
Okay, I want you to substitute and solve for x and let me know what you come up with.
Okay. So I got x equals negative 2.
Okay, that is correct. Very good. So if we wanted to, we could find y. Y would be 2. Okay. So let's go to some other problems here. Let's set up. I want you to set up the system of equations for this. Okay. Baseball team scored 5 more runs in its second game than its first. The team scored twice as many runs as the first game and the third game. The total number of game runs scored in all 3 games was 29. So I'm sorry, I want you to tell me the first, second, and third equations for this. For the first game, second game, and third game. One of them will be X.
One of them will be what?
X.
So then one is X. And then. So it's X plus 5 is the second number of games. And the third is 2X minus 5.
Team scored twice as many runs as the first game in the third game. So just twice as many as the first game.
Oh, so then 2X.
2X. And
So
we know that the
numbers,
total,
so then it'd be X plus 5 plus 2X. And 4X plus 5 equals 29.
so this is a classic multiple choice problem where the first answer is A.
So then X, so then A is 6, second is 11, third is 12.
All right, so let's say these were the multiple choice answers. What's the right answer to this problem?
How'd you get 10 for B?
This is just the answer space. Don't worry about where
Oh, the
I made it up.
answers would be second game is 11, so C.
Good. Yes, very good. Important that you see that. All right. Here's one. So I think you can kind of set up the same way on your own and try. Seem to be doing real well with the story problems here, but this one's a little bit more difficult. So give that a try, please.
And 104 miles per week. So 104 divided by 2 is 54. There's 52. 52 minus 14. 38. Does Lauren run 38 miles a week?
So if Lauren runs 38, she runs 14 fewer than Kristen. That means Kristen is going to run 52. Those do not add up to 104. Try again. In fact, these actually add up to like 92. So we're kind of way off. Need to go a little bit up on Lauren.
52.
So you could write an equation here. L plus K equals 104. And L is K minus 14.
So then K minus 14 plus K equals 104. So then 2K minus 14 equals. So then 128. So then K equals not 52, but 64. So then Kristen will run 64, which means Lauren runs 50.
That's right. Well, 50 plus 64 does not equal 104, equals 114. An extra one in there. So if we set up the system this way, it's K minus 14 plus K equals 104. So that's 2K minus 14 equals 104. 2K equals 118. So K does equal 64. But we want Lauren. Lauren is K minus 14.
Lauren
Wait a
is
second. 50. That's not right. I made a mistake here. Sorry, this is not right. It's 50, 59. I'll let you talk me into that. So 59. And then Lauren is 45. 59 minus 14. All right, let's kind of transition here to some other stuff. Some other problems I found. I mean, we can just do a smattering of things. How about this? How do you simplify the square root of 500?
I'd probably divide by 4 first, because 4 is an exact or perfect square.
So if you're going to find a perfect square, you should find the largest one that works.
Um,
And there's kind of a bigger one I think
100.
could, yeah, 100. So if you're gonna do anything, it's square root of 100 times 5.
So then 25 times square root of 5.
Square root of 100 is
10. Oops.
10.
10
root
square root
5.
of 5.
So let's say I asked you for the square root of 4,900, no calculator.
4,900 has a square root.
Right, no calculator though. Try to do it by hand.
700. No, 70. 70.
Yes, yes. And that would be an answer. I would definitely put that in the multiple choice there. Okay, good. All right, so where this is going is problem like this, where you have to simplify some roots, square root of 18, square root of 54, square root of 50, and then see what you can combine. Some of them may combine nicely. So square root of 18, you can do the same thing. You can find the biggest square root that goes in there. It's up to
So
you.
then that's 2 square root of. So sorry, 3. 3 square root of 2. So
Okay.
then it'd be 3 square root of 2 times or minus I feel like 54. 54 is not divisible by 4.
It is not.
5 by 2 is 27.
Okay.
5 by 9, maybe? Yes, it's divisible by 9. 6 times. It's 3 square root of 6.
Okay. 3 square root of 6, I agree. Plus, now that 2, just leave that 2 alone and work on the square root of 50.
Plus 5. Or it'd be 10. That's 2 times 5. Be 10 square root of 2.
10, 100 does not go in here, so there's no way to get a 10 out.
Or not 5. Yeah, but then 2 times 5.
Right, but like if you're going to do it the way you're doing, which is fine, that's the more advanced way. You have to say that it's 20. See that it's 25.
Yep.
Square root of 25 is 5. 5 square root
Yep.
of 2, and then you multiply by 2 to get the 10.
Yeah, 10
Maybe.
square root of 2.
Okay. All right. Okay. What do you do from here?
Not really sure how you add the out. Do you just add the outsides?
They do. They are like terms, even though they're not great. They are like terms.
But how'd you get 3?
Sorry, 2. The brain sometimes patterns what
Oh,
you've been doing,
okay.
and you say, "Oh, 3, 3, 3." I don't know. It happens. All
And
right.
that's it.
Yeah, last one here. For you to try. This will close out our lesson for today.
Uh, uh, I don't think you can combine those.
So this becomes 2 square root of 9 plus the square root of 18. You multiply the roots.
Oh, okay.
Okay. What
So
does the
then
square
it
root of
become 3 square root of 2, 2 square root. So then it become 5 square root of
this is 6. What does the square root of 18 become?
uh A 2 times, oh, yeah, and the, 2 or 3 square root of 2,
3 square root of 2. And these combine,
no.
They cannot. All right, well, that's going to do it for us for today. We're all done here. We got your assignment knocked out. Tomorrow, definitely want to come up with some new stuff for us to work on. Otherwise, it'll be more